Okay, now today we're going to take a look at calculating slope again, but with a little bit of a twist, not a big thing. Typically, when we think about the coordinates of a point, we tend to think about whole numbers. For example, like the point 3,7 over 3 up 7, or the point negative 512, which is left 5 and down and up 12 from the origin. And we're calculating slope. Right? We would say that slope, and we talked about this before, is change in y over change in x. And to calculate the change in y, we just have to calculate how far apart the two y coordinates are. And we'll just subtract one from the other. So we'll go 12 minus 7. And then for the change in x, we'll just do the same. We want to find out how much the x coordinates change. We subtract one from the other. So negative 5 minus 3. Now, one thing that's kind of important, and this doesn't necessarily jump out at you perhaps if you're not looking at the points on a graph, but when you do this subtraction, you have to go the same direction both times. So 12 minus 7, negative 5 minus 3. Or go the other way, 7 minus 12, 3 minus negative 5. Either one would be okay, but as long as they go the same direction both times. So 12 minus 7 is 5, negative 5 minus 3 is negative 8, and usually we'd write the negative sign out front of the fraction. Or up in the numerator. We don't usually write it down in the denominator. That would just be a little odd. Alright, but well, that's just a regular slope calculation with normal integer coordinates. But it doesn't have to be that way. Here we've got a couple of x coordinates that are irrational numbers. So 2 plus the square root of 3, which altogether is something like approximately 1 point, well, the square root of 3 is like 1.7 something, so it'd be 2 plus that, or 3.7 something or whatever. But that's a perfectly legitimate number, and it's a perfectly legitimate location on the coordinate plane to go over this far, and then up 7 units from there. Even though it's not going to be easy to plot, it is a location on the plane. And we could have a line that went from this point to some other point here that also had different coordinates. So 3 plus square root of 3, whatever that turns out to be. So we have our change in y over our change in x. Our change in y is negative 2 and 7. So we'll go negative 2 minus 7. Our change in x is going to be 3 plus, I want to write this all in parentheses, 3 plus square root of 3 minus 2 plus square root of 3. Alright, so our one x coordinate minus the other. So a little combining like terms. Negative 2 minus 7 is negative 9. And notice that when I'm subtracting here, I could subtract 3 minus 2, and that's 1. And then square root of 3 minus square root of 3, well, let's cancel each other out. I have a positive version and a negative version, so I get negative 9 over 1, which is really just negative 9. So, bring this up a little bit. So I can still do a slope calculation even if my coordinates aren't perfect integers. We can also, in fact, over here, do a slope calculation without even having any actual numbers at all. Right? I've just got a lot of variables here, which is possible you can run into situations where your coordinates are variables. I have some coordinate, I don't know what it is, or perhaps it's changing. So there's some rule or something like that that makes it change. X plus 5, that could be a coordinate. Anything can really, lots of different things can be coordinates. So let's do our slope calculation. So delta y over delta x, let's see. We'll go n minus m in that direction. So this is our x coordinate. Okay. Over here we've got our y coordinates. In this example, I probably shouldn't have used x's in here. Let's call these t. I should have used x as my variable there. So here I've got 3 plus t and t plus 5. So I've got 3 plus t minus t plus 5. So let's see, n minus m, that can't be simplified anymore. But down here, let's see, I've got a positive t and a negative t. They're going to cancel each other out. And I have 3 minus 5, which is negative 2. There we go. Although technically we'd probably want to take this negative sign out of the denominator, so to bring it up into the numerator, which then makes this a negative n and a positive m. So it would be, reverse the order here. There. Okay. So see, slope is change in y over change in x, but the change in y and the change in x can be calculated from just regular integer coordinates, or maybe fractions or decimals. I might have irrational numbers or some combination of irrational numbers and integers, or I could have some kind of variables. There's all sorts of things we can do, and we can still do the calculation and come up with some sort of an answer. Right? Calculating slope.